Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Minimum add to make parenthesis valid, Leetcode 921. In this problem, we are given a parenthesis string S, that is the string only contains parenthesis. In one move, we can insert a parenthesis at any position of the string. For example, if the string given to us is with one opening parenthesis and three closing parentheses, then we can insert an opening parenthesis to make it like this one, or add an closing parenthesis to make it like this one. In the end, we should return the minimum number of moves required to make string S valid. And the rule for parenthesis string to be valid is, it can be an empty string or it can be written as AB, where A is concatenated with B and A and B are valid strings, or it can be written as a string A between opening and closing parenthesis, where A is also a valid string. Then in example 1, for the given string, output is 1 because we can just add one opening parenthesis to make the string valid. Similarly, in example 2, for the given string, output is 3 because we can add 3 closing parentheses to make the string valid. Now, in terms of solution, this problem is very similar to valid parenthesis problem, where we had to check if the string is valid or not by balancing the parentheses. And we know that the most common approach for handling such kind of AB strings is using stack. But as I told there as well, the reason we needed stack there was we had multiple type of parentheses. Like I think we had this one, we also had this one. But here we only have one type of parenthesis. So even though this problem is easy to solve with stack, but that still requires extra space. So first we will solve this problem using stack, but then we will simplify it to use just the counters to reduce the space complexity to O of 1. So now let's first solve this problem with the stack and take the string like this one. What should be the output in this case? It should be 2 because we can add one opening parenthesis here and one closing parenthesis here. And now let's take a stack. Now we will start iterating on the string, and each time we encounter an opening parenthesis, we will push it onto the stack. And if we encounter an closing parenthesis, then we can pop out the opening parenthesis from the stack. But if the stack is empty, then we will also use a variable called left counter, which will count the number of left or opening parentheses required because stack couldn't provide the matching opening parenthesis. The open parenthesis on the stack, pop it out. So now let's see this in action. So first we will see an opening parenthesis. So we will push it onto the stack. Then we see the closing parenthesis and there is a matching opening parenthesis on the top of the stack. So we pop it out. So these two parentheses were balanced. Now we again see the closing parenthesis, but this time the stack is empty. So that means we should increment the left counter by 1. So now our left becomes 1. Then we see an opening parenthesis. So we push it onto the stack and now we are done. So this opening parenthesis couldn't find any closing parenthesis and this closing parenthesis couldn't find any opening parenthesis. Because of that, we will return answer as 1 plus stack size, that is 2 in this case. Now let's jump into the code part. So first let's define the stack to keep track of unmatched opening parentheses. Today I am using array tag implementation of stack. We will also need a variable left counter tracking the unmatched closing parentheses. So now we will start iterating on the string, and if we see an opening parenthesis, we will push it onto the stack, else otherwise the string can have closing parentheses. So if the stack is not empty, we will try to match this closing parenthesis with the open parenthesis in the stack and pop it out. Else, if we are here, that means stack was empty, so we couldn't find any matching opening parenthesis. So we will increment the left pointer by 1, telling us that we need more of left or open parenthesis to balance this closing parenthesis. And in the end, our answer will be left plus stack size. So now let's run this code. Cool, let's submit this code. Awesome. In terms of time complexity, it will be O of n, where n is the length of the string s, because we have to go through each character only once. And in terms of space complexity also, it will be O of n, because in the worst case, the string may contain only the opening parenthesis, so our stack size can grow up to string size. So because of this, the space complexity is O of n. And now let's try to come up with a solution without stack. We have used the stack to store open parentheses, hence tracking the need for right or closing parentheses. So instead of using stack, how about we define a counter called right to track the number of right or closing parentheses needed to make string balanced, And now when we are traversing the string and we see an opening parenthesis, we increment the right counter instead of pushing it to the stack, highlighting the need for closing parenthesis or right parenthesis to match it. And if we see a closing parenthesis and right is greater than 0, then we will decrement the right counter, because now we have matched the previously encountered opening parenthesis. But if right is 0, then we will increment the left counter, because for this closing parenthesis, there is no corresponding opening parenthesis. And finally, we will return sum of left and right as an answer. So now let's see this in action. So first we see opening parenthesis. So we increment the right count to 1. Then we see closing parenthesis. So because right is more than 0, we will decrement the right counter to 0. Then we see a closing parenthesis again. So this time, because right is 0, we will increment the left counter by 1. And then we again see a right parenthesis. So we will again increment the right by 1. So in the end, left counter is 1, indicating one unmatched closing parenthesis. And right counter is also 1, indicating one unmatched opening parenthesis. So total number of corrections will be 2. So now let's jump into the code part. So instead of using stack, we can actually use a right counter, and we will go through the char array again. But this time when we see the opening parenthesis, we should increment the count by 1, signifying the need for closing parenthesis. And when we see stack is not empty, we will reduce right by 1, that is one closing parenthesis matched. And finally, left plus plus stays the same, denoting extra closing parenthesis. And finally, we will return left plus right as our answer. So now let's run this code. Yeah, it should be right greater than 0. My bad. Let's submit this code. Cool. In terms of time complexity, it is still O of n. But in terms of space complexity, now it is O of 1, because we are not using any extra data structure, just some variables here and there. So I hope this video was useful to you. If it was, please like, share and subscribe. The code link is in the description below. Thanks for watching. See you next time.